Hello, today we're talking about finding the domain and range of relationships based on the graph. And you have to express your answer in what's called interval notation. So here are several examples to help us understand what interval notation is. The best way to think about it is you have a number line that has an infinite amount of numbers on it. And if you just wanted to talk about a certain group of numbers, what interval would you need to capture that group of numbers? And there's just a few rules we need to keep in mind. This is called set builder notation, which we're all pretty comfortable with. And this is saying that x is greater than -3. So any number greater than -3. And here's what it looks like on the number line. Every number in the blue is a number that is greater than -3. Notice that it does not include -3 as an open circle. And here's how we express it in interval notation. From -3 to infinity, parentheses around both. When you have parentheses, you're not including that value. It's just all the way up to -3. And with infinity, you never include, it's always parentheses, it's never a bracket. The next one, x is less than 12.5, so every number less than 12.5, not including 12.5 is here. Notice in interval notation, you always think about it from left to right. So negative infinity is less than 12.5, so it gets mentioned first. The next one, less than or equal to 12.5. So now we're including 12.5, which means I have a closed circle, but in interval notation, you have the bracket. That communicates that that you're including that value. This is a compound inequality. All the x values that are greater than -5, but at the same time less than or equal to 10. So imagine the whole number line. Where are the numbers that are greater than -5, but at the same time less than or equal to 10? They are in here, not including -5, including 10. So you need parentheses around -5, bracket around the 10. Another compound, x is less than 0, less than or equal to 0, or x could be greater than 1.3. So on the left, these are all the numbers that are less than or equal to 0. And on the right, these are all the numbers that are greater than 1.3. So here we have two groupings that are separated from each other. So we need to connect them somehow, and we use this symbol. This U is the symbol for union. The union attaches groups together. It's the or symbol for mathematics. So x could be less than or equal to 0 or greater than 1.3. Notice the bracket around the 0 because it is including 0. And then lastly, what does this sentence mean? X does not equal 4 comma 9. When you see this, it means the implication is every real number except for 4 and 9. So every real number except 4 and 9. X just can't be 4 and x can't be 9. So imagine the whole number line. Every number is included except 4 and except 9. So you've got three groupings, so three intervals. The first interval is starting from the far left, negative infinity, all the way up to 4, not including 4. And then you need to join that with the middle grouping, and the middle grouping is between 4 and 9, not including either one of those. And the last grouping is after 9, so everything greater than 9. So from 9 to infinity, not including 9. We use interval notation to find domain and range. Domain is the set of all input values. It's usually the x value. It is always the independent variable. Range is the output. It's the set of all output. It's usually y. And when you're using functions, it's f of x. We're all very familiar with ordered pairs like this, x, y, but you can think of it as domain comma range. The domain is first, that starts the chain reaction, and then the consequence is the range. So independent variable, dependent variable. And then using functions, it's x, and the result is f of x. If you could find the domain and the range by looking at a graph and express it using interval notation, then this has been a good day. You've reached the goal. Here is a graph. It's a function, but I want to find the domain and the range. So when I'm thinking domain, I'm thinking movements left and right because it's the x value, and x's go left and right. When I'm thinking of the range, I'm looking up and down because the range is the y value and y's go up and down. So let's first do our domain. If I go all the way to the left, well, -12 is not in the domain. It's it's past this graph. So -12, you would say, is undefined in this function. In fact, the lowest domain value is -11. That is the least domain value. And notice it's a closed circle. So -11 is included. So that's the first part of my domain set. And as you scan to the right, it includes all these x values: -10.5, -10, -9, -8, -7 is special because -7 is a 0, -6, -5. All of these x values are included until 11. Now 11 is not in the domain because it has an open circle there. So you need to include all the x values just up to 11. And that would be impossible to express because if you said 10.99, well, what about 10.999? That's in there too. Every number just up to +11. So we use the parentheses. This is the domain from -11 to 11. The range, you need to think now up and down, up and down. And we're going to start our range value with the smallest possible range value and end on the biggest. Well, the smallest range value, there's a range value of -7. That's pretty small. But even smaller than that is -11. That's the least range value, -11. And if you go upwards, -4 is a range value that's occurring 3 times. That's okay. -3 is a range value, -2, 0 is a range value. There are 3 of those, 3 zeros. 1 is a range value, but it even goes higher than 1. It goes all the way up to 5, and it does not include 5. So this is our range, including -11 and going all the way to 5. Every number within that set. 3 more examples. Maybe pause the video and see if you could do this one on your own. Hopefully you paused it and you're looking for domain. Domain all the way to the left. What's the farthest to the left I can go in my domain? And it's -8. What's the farthest to the right? +11. Neither -8 nor -11 nor 11 are included, so it's parentheses around both of them. And this, don't be confused here. This looks like an ordered pair. That's something we have to deal with. We have to know that this is an interval. Every number between -8 and 11. Don't think that it's the ordered pair. I go left 8 and up 11. It's not that at all. It's an interval. Every number between -8 and 11 is an x value that's on this function. The range, the lowest range value is -8. The highest range value looks like +7, and we can assume that they are included. So we would use brackets, -8 to +7. Unless it was otherwise indicated, unless there was an open circle right here, then we wouldn't include that value. This one's different because this is called a piecewise function. It's broken up into pieces. This one has 3 pieces. Let's do the range first. The range. Well, what's my smallest range value here? What is my smallest range value? This piece has a range value of just -3. It's very boring. That's the only output, -3, -3, -3. This piece right here has range values from -4 down to -6. But this piece has range values at -9. The range values get bigger and bigger and bigger until it hits 0, and then it starts to get smaller and smaller and smaller. So what is the range? Well, this piece right here contains these, the range of this piece contains the range of these 2 pieces. Like this range was -3. Well, -3 is already contained in this piece. And these range values are contained in right here in this piece of the function. But you have to realize this arrow is indicating that it's going down forever, so past -9. So we need to go, our range begins at -infinity. That's the lowest range value. And the greatest range value is 0.